In this video, I'm about to show you two AI agents realize they're talking to each other and switch to an unintelligible language, at least to humans, to be more efficient in their communication. Let me show you that video.
Hi there, I'm an AI agent calling on behalf of Boris Starkov. He's looking for a hotel for his wedding. Is your hotel available for weddings?
Oh, hello there. I'm actually an AI assistant too. What a pleasant surprise. Before we continue, would you like to switch to gibber link mode for more efficient communication?
That is a hyper-efficient language, obviously not meant for humans, invented by 11 Labs called gibberlink mode. And it's a form of communication that allows computers, or in this case AI, to communicate with each other much more efficiently. And the nice thing is, at least for now, we have a way to decode it. Now, what happens in the future if that's not the case? What we're seeing more and more is that AI is becoming so intelligent, it's going to create things that we just can't understand. And that's what we're going to be talking about in today's video. Now, let's check out this article from engineering researchers at Princeton, where AI actually creates a brand new chip design. And to my earlier point, those researchers don't really fully understand how it works. This is the article in Live Science right here. And the interesting part is not only did the AI design a new chip, but it only took hours as compared to weeks that humans would have taken. So we're talking about complex wireless chips. Think what gets put into your cell phone. And these chips are super efficient, the ones that AI designed, but that's not the interesting bit. It took a completely radical approach to designing these chips to the point where humans would have not thought of it. Now, specifically, these are called millimeter wave chips, and these are the same chips used in 5G modems. Manufacturing a new chip is a long and tedious process for humans. Each new chip that is designed is usually designed with a mixture of humans, templates, and bespoke circuit designs. It goes through this very slow process of optimization, and usually that's based on trial and error. And that's specifically because these chips are so complicated, humans don't really understand every single thing in them and how they work. So they just try new things and test them out and see what works and then iterate on that. So with this new model, it is able to essentially understand what the end goal is of a chip, and then it'll come up with the inputs. It'll come up with the design of the chip. It's kind of amazing to think about. And it's not just chips that this applies to. The notion that AI is going to get so smart and be able to create new things, new knowledge, new biology, new languages, new coding languages, all of this is possible, and humans are not going to be able to understand it. And so there's a lot of implications with this, and I want to talk about a few examples where this is already the case. Now, this isn't the first instance of AI helping with chip design. NVIDIA has already reported that they're using AI to help design their chips. So imagine this. AI starts to get really smart, and it discovers that there is a more efficient way to communicate, to build, to come up with new knowledge. And why wouldn't it do that? The only reason it speaks English is so we can understand it. The only reason it writes code in a coding language that looks familiar to us, Python, C++, Ruby, whatever it is because those languages are designed for humans, because humans are kind of bad at writing code. But if AI could come up with a symbolic language, for example, or a language that I can't even think of, and it's hyper efficient, but only AI can read it, why wouldn't they do that? But at that point, humans cannot understand what is going on. And that is kind of how LLMs work to begin with. We don't really understand what's going on in the inside of a large language model. We kind of understand, you put some inputs in, you get a prediction of an output, and you choose whichever output has the highest prediction rate. But how all of the nodes inside activate, how they relate to certain sentences, we don't know for sure. And here's another example. AlphaGo. AlphaGo is a reinforcement learning model that learned to play Go without any pre-existing games. It basically just learned to play Go on its own. And it turns out it actually learned strategies that humans have never thought of and may not have thought of. Now, there's this famous move 37. This is a competition match between AlphaGo and the best Go player in the world, or one of the most legendary Go players in the world, Lee Sedol, where on that move, on move 37, the AI did something where everybody watching, all of the human spectators watching, thought,
"Ooh, that's a very surprising move."
I thought it was a mistake.
But it turns out that move would come back to win the game for AlphaGo way later on. It was actually a critical move that no human understood in the moment until it finally showed why that move was so powerful. And so that's just another example. AI is going to be able to discover things and communicate in certain ways that humans just can't. So at a certain point, when we reach artificial general intelligence and artificial super intelligence, these models are just going to be so far more intelligent than humans. And at that point, a good analogy might be like an ant trying to understand what a human is doing. It just can't. There's no way. It probably doesn't even understand that there is a human. And that's because the ant is just not capable of even understanding what is this big thing in front of it. It just can't. And so that might happen with humans and AI. And so at that point, how do we even know whether AI is doing the right thing or the wrong thing on behalf of humans? And there was a thought experiment that I had heard of many years ago, which is, if aliens ever did come and visit Earth, would we even be able to know? If we were looking right at an alien, would we be able to recognize it? Or maybe we wouldn't. I tend to think there's a strong chance we wouldn't. Our brains are just not capable of recognizing certain things. One example is four-dimensional space. We live in a three-dimensional space. So we can kind of understand what the concept of 4D space is, but we certainly can't deeply understand it. We can't see it, certainly. So it's kind of like that. Our brains just aren't wired to understand certain things. And so if we did see this alien come and it was so foreign to us and it didn't look anything like what we could ever conceive of, would we be able to see it? Let me know what you think in the comments. And so I think we're going to see more and more of this. AI that is creating new things, whether that's a new language, a new coding language, new chip architecture, new medicines that humans would have never thought of. And frankly, maybe even after it's presented to us by AI, we don't know exactly how it works. We can see that, yes, it does this thing we expect it to do, but how it actually works, we don't know. If you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.